Hello students, I am Vishwanath. Welcome to my YouTube channel Best Physics Guide by Vishwanath. If you have any numerical problem about physics or mathematics related to class 11, 12 or joint or medical, then please send those problem to my Facebook page Best Physics Guide by Vishwanath. I shall try to solve those problems through my YouTube videos. ছাত্রছাত্রীরা, তোমাদের যদি ভৌতবিজ্ঞান বা অঙ্ক সংক্রান্ত কোনো গাণিতিক সমস্যা থাকে যেটা ক্লাস 11, 12 বা জয়েন্ট বা মেডিকেলের পরীক্ষা সংক্রান্ত, তবে তোমরা আমার ফেসবুক পেজ বেস্ট ফিজিক্স গাইড বাই বিশ্বজিৎনাথ এখানে শেয়ার করতে পারো। আমি তোমাদের সমস্যাগুলোকে সমাধান করার চেষ্টা করব আমার ইউটিউব চ্যানেলের মাধ্যমে। আশা করি তোমাদের সাহায্য হবে এবং তোমরা এতে উপকৃত হবে। Today I am going to discuss about photoelectric effect. This is an interesting phenomenon which would change the character of light and which is one of the important experiment or phenomena related to quantum physics. Let's watch the video, and if you like my video then please click the like button and please subscribe my channel. First, German scientist Hertz show the photoelectric effect, and then Leonard also proved it by experimentally, and this is the Leonard experiment. This is a vacuum glass tube. This is two metal plates, A and B. A is anode and C is cathode. Cathode is a very photosensitive metals and which is made by sodium, cesium or potassium, etc. And there is no connection between anode and cathode since this is a vacuum tube. And this is a circuit diagram. This is a milliammeter and this is a voltmeter, and this is a battery or some cells are connected in series, and this is negative pole of the cells connected with cathode and positive poles of the cell connected with anode. Although this circuit is completed, but there is no flow of current through the circuit and through the ammeter since there is a huge gap between anode and cathode. But an interesting phenomena will be observed when high frequency light falls on the cathode. When high frequency light as gamma ray or X-ray or ultraviolet ray falls on the cathode, then the milliammeter responds and some current flows through this ammeter. That's why we can say that when some light or high frequency light incident on the cathode, then there is a flow of electron from cathode to anode. This is known as photoelectric effect. That is due to the incident of the high frequency light on a metal plate, some electrons emits from the metal plate. This phenomena is known as photoelectric effect. And we can observe some characteristics of the photoelectric effect. At first, when we increase the potential difference across the anode and cathode, then the current passing through the ammeter also increases, but it does not follow the Ohm's law. That is the curve between V and I, that is potential difference and the current, is not linear. Okay, that is the graph between V and I is not linear, it is a curved nature. That's why the photoelectric current does not follow the Ohm's law. Again, when we decreases the potential difference, then the current also decreases. But when the potential difference between the anode and cathode is zero, but some light continues to fall on the cathode, then the electron moves from cathode to anode and current flows through this ammeter. That is when the potential difference is zero, that is V is equal to 0, then we can observe the current electric effect, or we can find the current photoelectric current. That is, the some electrons can be removed by the light, incident light, although there is no potential difference between cathode and anode. Now, if the cathode is keeping zero potential and anode is gradually moves into negative voltage, okay, that is, anode is given negative voltage with respect to cathode, then the photoelectric current also decreases, and after some time the photoelectric current stops, although the light ray incidents on the cathode. Okay, this potential, negative potential at the anode with respect to the cathode, is known as stopping potential. Let's see the graph between V and I. In this case, VA is accelerating potential. When the accelerating potential increases, then the photoelectric current also increases. And after some time, the photoelectric current remains constant. This is known as saturated current. When the photoelectric current does not change with the applying accelerating potential, then this is known as saturated current. But in this case, this is not a saturated current. Here, when increasing V, the current also increases. When the potential is zero, then we can also get some amount of photoelectric current. After decreasing the potential, that is VR is the retarding potential, the current also decreases. At some value of retarding potential, the current becomes zero. This potential is known as stopping potential, that it is denoted by Vs. That is, the negative potential at the anode with respect to cathode when the photoelectric current becomes zero is known as stopping potential. It is denoted by Vs. Now let small be the charge of an electron and small m is the mass of that electron, and Vmax is the maximum velocity of the emitted electron from cathode to anode. Then from the conservation of principle of energy, we can say that the total potential energy of that electron and the maximum kinetic energy of that electron will be equal. That's why E into Vs is equal to half m Vmax square. Here Vs is the stopping potential of that electron. This is equal to E maximum, where E maximum is the maximum kinetic energy of the emitted electron from cathode to anode. From this relation, we can find out the maximum kinetic energy of that photoelectric electron emits from cathode to anode, and we can easily measure the stopping potential of this experiment. Now we can discuss about the variation of stopping potential with the frequency of the incident light ray. We plot the frequency of the incident light ray, that is nu, along x-axis, positive x-axis, and threshold potential Vs along positive y-axis. We get a straight line. The graph is a straight line, and the graph starts not from the origin. It starts from the some frequency mu 0 which is greater than 0, or this is mu 0, value of mu 0 is greater than 0. That means the photoelectric effect cannot start by any light ray or any ray having any frequency. Okay, to start photoelectric effect, a minimum frequency would be needed. Minimum frequency will be needed. This minimum frequency or nu 0 is known as threshold frequency. Below the threshold frequency, the photoelectric effect is not observed by a metal, and the threshold frequency, value of threshold frequency, will be changed due to from metal to metal. Okay, if the metal is very photosensitive, then the value of threshold frequency will be small, and if the metal is not much photosensitive, then the value of threshold frequency also be greater. Okay, and we can write the relation between the threshold frequency and the stopping potential, that is E into Vs is equal to H into nu 0, where nu 0 is known as Planck constant, and this is equal to hc by lambda 0, where c is the velocity of light in vacuum and lambda 0 is the wavelength of the light having threshold frequency. From this graph, we can also explain some practical phenomena, like in a dark room where the photo films is developed. This dark red light is used in a dark room because the frequency of red light is small. That's why it does not effect on the photographic plate. Okay, but the frequency of yellow light or blue light is much greater than red light. That's why yellow light, blue light affects the photographic plate. This graph shows the relation between photoelectric current and the intensity of light ray. We plot the intensity of light ray along positive x-axis and photoelectric current along positive y-axis. when the intensity of this graph is a straight line passing through the origin. That is, when the intensity of light ray increases, the photoelectric current also increases. Actually, photoelectric current is directly proportional to the intensity of incident light ray. This graph shows the relation between stopping potential Vs and the intensity of light. Here you can see that this graph is parallel to the x-axis. That is, the stopping potential does not depend on the intensity of incident light ray. That is, the stopping potential does not depend on the intensity of light ray. Now we can summarize the characteristics of photoelectric effect. First, photoelectric effect is an instantaneous process or instantaneous phenomena. That is, when the light falls on the cathode, then the photoelectric current produce, and this takes only few microsecond, okay, and few nanosecond or few microsecond. That's how you can say that photoelectric effect is an instantaneous process. Next, the stopping potential does not depend on the intensity of incident light ray. Third, the photoelectric current is directly proportional to the intensity of incident light ray. Fourth, there is a minimum frequency which starts the photoelectric effect. Below the minimum frequency of incident light ray for a certain metal, the photoelectric effect does not start. This minimum frequency is known as threshold frequency. Now, if we consider that light is an electromagnetic wave, then by electromagnetic wave or by wave theory, we cannot explain the photoelectric effect. First, by wave theory, the photoelectric effect should be a time-taking process. That is, after incident light ray on the cathode, the emission of electron takes minimum 2 to 3 days. But we can see that photoelectric effect, we also already observed that photoelectric effect is an instantaneous process. Second, according to wave theory, the stopping potential should be directly proportional to the intensity of light ray. But practically, the stopping potential does not depend on the intensity of light ray. Okay, and from wave theory, there should be no threshold frequency. Any frequency of incident light ray can emit the electron from cathode. But we already observed that there is a threshold frequency which is needed to start photoelectric effect. That's why the ancient wave theory or electromagnetic theory does not explain the photoelectric effect. So some new concept or new theory was needed to explain the photoelectric effect. Einstein explained this photoelectric effect by quantum mechanics, and he correctly explained this phenomena by quantum mechanics. So we can say that this phenomena that is photoelectric effect, is a very strong proof of quantum mechanics. And now we shall discuss about the Einstein's photoelectric uh, explanation, Einstein's photoelectric explanation or photoelectric theory, by which or uh, by this theory he won the Nobel Prize. Max Planck or Planck uh, already given already gave the for quantum theory in case of radiation. He stated that the energy of a quanta is directly proportional to the frequency of the radiation. That is, all radiating body emits radiation as a particle, or this energy packet or particle is known as quanta, and the free energy of each quanta or each energy packet is directly proportional to the frequency of the radiation. And he gave this formula: E is equal to h into nu, where E is the energy of each quanta and nu is the frequency of the radiation, and h is known as Planck constant. H is known as Planck constant. And Einstein used this concept in case of photoelectric effect. He considered that light emits as a quantum, that is, light moves as the some energy packets, and each energy packet has some energy which is directly proportional to the frequency of the light ray, and the energy of each photon, and this he used the he considered this teeny small quanta is photon, and he considered that the energy of each photon is equal to E into h into nu, where E is the energy of each photon and nu is the frequency of incident light ray, and h is the Planck constant. That is, Einstein considered that light is a particle nature. Light has a particle nature. That is, he shifted the nature of the light from wave theory to particle theory, by which he correctly explained the photoelectric effect. He first considered that the each photon particle collides with the electron inside the metal, and this collision is perfectly elastic collision. Due to the elastic collision with the photon and the electron, actually free electrons in metals, the electron gains some energy, free electrons gains some energy, and it can overcome the attraction of the crystal or of the metals, and it emits from the metal surface, and the anode, the positive anode attracts the electron and it moves from cathode to anode, and that's why photoelectric current is generated. First, that's why the photoelectric effect is an instantaneous process. Second, since the energy of each photon is directly proportional to the frequency of light ray, that's why the stopping potential is directly proportional to the frequency of incident light ray. And some photon having low frequency and small frequency have not enough energy to excite the electrons from the metal surface to anode. That's why incident light ray has minimum frequency, which the incident light ray has required some minimum frequency which can excite the free electrons to overcome the attraction of the metals to the electron, and that's why the electron moves from metal surface to the anode, and current, photoelectric effect or photoelectric current is generated. Now Einstein gives a famous formula which is known as Einstein's photoelectric equation. Since he considered that the collision between an free electrons and inside a metal and the incident photon is perfectly elastic, that is, no kinetic energy of photon is lost due to friction or due to heating effect. Therefore, if the total momentum of the linear momentum of the incident photon is converted into the electrons, emitted electrons, then it can be written from the conservation theory of conservation of energy, that E is equal to E0 plus Ek, where E is the energy of an incident photon and E0 is the minimum energy which is required to emit electron from metal surface, and Ek is the maximum kinetic energy of emitted electron. That is, the energy of incident photon is used into two parts. One part excites the free electrons to emit from the metal surface, and another part of the energy of incident photon is used to kinetic energy of the emitted electron. Therefore, we can write E is equal to E0 plus Ek. Or we know E is equal to H into nu, E0 is equal to H into nu 0, and Ek is equal to E into Vs, where nu is the frequency of the incident light and nu 0 is the threshold frequency of that metal, and Vs is the stopping potential, and E is the charge of an electron. Therefore, putting these values in the above equation, we have H into nu is equal to H into nu 0 plus E into Vs, where H is the Planck constant, or Hc by lambda is equal to Hc by lambda 0 plus E into Vs. Here c is the velocity of the light in vacuum and lambda is the wavelength of the incident light, and lambda 0 is the wavelength of the light which has threshold frequency. These two equations are known as the Einstein's equation for photoelectric effect. And you know that here Vs is related in linearly to nu. That's why Vs changes with frequency, and Vs does not depend on the intensity of incident light ray. Vs depends on the frequency of the incident light ray, that is nu. By this formulae, Einstein correctly explained the photoelectric effect and he won the Nobel Prize. Photoelectric effect is used in solar cell, in ballonogram, etc., and it can also used in to produce the automatic switch in the street to on or off the street lamps. I think you understand this topic, so I am going to complete my discussion for today, and thank you for watching my video. Have a nice day.